video, I'm going to talk to you how we sum an arithmetic sequence or series. So we use the notation Sn for the sum of n terms. We use a formula depending on what information we have. So n being the number of terms divided by 2, multiplied by twice a being the first term of the sequence, plus n minus 1, d, so the number of terms minus 1, times the common difference, where d is the common difference. So we need to define that d is the common difference. So that's the actual number that you are adding each time to get to the next term in the sequence, in the arithmetic sequence. There is an alternative formula that we can use where if we have the first term of the sequence and the last term of the sequence, we can simplify this formula to look like this for n terms, the number of terms in the sequence. So a is always the first and L is the last. Now you don't always have that information, so it might be that you can't always use this formula. I'm going to show you how to work these formulas with an example now. So in this example, I'm going to calculate the sum of the first 14 terms of this arithmetic sequence, 2, 5, 8 and 11. So what have we got? We've got a equals 2. It's the first term. We don't have the last term for the first 14 terms, but we do have the common difference. We can identify that each of these numbers in the sequences is going up by 3. So because I don't have the last term, I'm going to have to use this formula here. So I'm just going to substitute the values in. I want the sum of the first 14 terms, or n is 14. So 14 divided by 2, multiplied by 2 times the first term, which is 2, plus n minus 1, n being 14, so 14 minus 1 is 13, times the common difference, which is 3. So let's work out the bracket first. So the sum of the first 14 terms, 14 divided by 2 is 7, so it's 7 multiplied by 4 plus, oh, I should have written a number in there, it's supposed to be 3, I've written d in there, oops, never mind, replace that. So 13 multiplied by the 3 is 39, so we're going to do 4 plus the 39, and we can work that out as 7 times the 43, yes, 7 times 43, which is 301. So the sum of the first 14 terms of this arithmetic sequence is 301. For this example, I have another arithmetic sequence. We've got 27, 23, 19, 15, continuing up to the term negative 33. We don't know how many terms there are, and so what we're going to do is find out how many terms are in this sequence, and then we're going to sum those. So just a reminder that with any arithmetic sequence, we can write the general relationship for a sequence like this of the nth term, where a being the first term, d is the common difference. Now we can see that the common difference here is negative 4. So if d is negative 4, what else do we know? First term is 27, and we have the last term, which is what number, I don't know. So let's look, let's sub that number in. So we've got negative 33. The first term is 27, plus n minus 1, n is what we're trying to solve for, times the common difference, negative 4. So I'm going to expand this bracket here. I could subtract the 27 first. So if I subtract the 27, I get negative 60. So negative 60 equals, and at the same time I'm going to expand this bracket, minus 4n plus 4. Subtract 4 further gives me negative 64 equals negative 4n. Multiply both sides by negative 1 or switch them over. I like to switch them over. So 4n equals 64. Therefore, n equals 64 divided by the 4, which is 16. That tells us that this is the 16th term in the sequence, and that altogether, this is the first term, that's the last term, there are 16 terms. So what we're now going to do is sum the first 16 terms, and we have the first and the last, so we can use the formula. Sum of the first 16 terms is n over 2, so 16 over 2, multiplied by a plus l, a being the first, which is 27, plus the negative 33. Alright, and then I can work out 16 divided by the 2 is 8. 27 plus negative 33 is the negative 6. So I'm doing 8 times negative 6, which is negative 48.